Green roofs are increasingly installed in cities around the world. The green roof, located on top of the Convention Center in Syracuse, New York, is one of the largest green roofs in the United States, totaling 5,600 meters squared in area. However, the roof was not green until 2011. Before 2011, it was totally bare. 1 year later, sedum plants typically used in green roofs, flourish. Spring, summer, autumn, winter. It is impressive and beautiful. But besides the aesthetic appeal, there are other benefits to green roofs.
Green roofs are very beneficial. One, they improve stormwater management by reducing runoff. Two, they increase water quality. And three, they increase biodiversity of the urban environment. Green roofs are also very good at mitigating the urban heat island and providing a very pleasing environment for people that work in the area. Who doesn't love a good green roof?
The Convention Center green roof is valuable because it is one of the few green roofs being monitored since 2013. Current monitoring records runoff using an electromagnetic flow meter. Precipitation on the roof is measured with two devices, a tipping bucket and a weighing rain gauge. The soil moisture in the growth medium is measured by 5 volumetric water content reflectometers, a pyrometer, which measures the incoming solar radiation, an infrared radiometer, which measures the surface temperature, 2 relative humidity and temperature sensors, and 3 wind anemometers are located on the tripod on the roof. During construction, temperature sensors were installed vertically throughout the layers at 5 points on the roof. This long-term, real-time data can help people understand the true hydrologic and thermal functions of the green roof and can help improve future design of other green roofs. Why is the green roof so important? Let's walk into Professor Cliff Davidson's office and find out the answer.
There is a combined sewer overflow problem in Syracuse, and there are only a couple of ways that we can really solve that problem. One way is by replacing some of the combined sewers with separate sewers, so that when the stormwater comes, the stormwater is carried in separate sewers out to the receiving waters, which in this case is Onondaga Lake. Another way to solve this problem is to have green infrastructure at various locations, so that when it rains, a lot of the rainwater does not get washed into the combined sewers, but rather goes into the soil of the green infrastructure. So in fact, Onondaga County is one of the foremost counties to do some experimentation with green infrastructure. And in learning about that, I became very intrigued by the possibility of doing research with green infrastructure. So we have a very exciting research program underway where we're looking at the Convention Center green roof.
That's amazing. Professor Davidson and his group are doing research in hydrology, chemistry, and energy. Let's hear what exciting projects they're working on. Alex is a graduate student interested in chemistry.
What I'm doing is I'm measuring chemical contaminants in the runoff from the green roof, and I'm comparing that to contaminant levels from essentially a traditional asphalt roof. And so the reason why this is important is we want to understand, are green roofs not only able to retain stormwater, are they also able to filter pollutants and runoff that eventually could get discharged to Onondaga Lake and cause pollution. So here's runoff from a traditional roof, and so it looks pretty clear. There's some particles settled to the bottom from debris on the roof. And then here's the runoff sample from the green roof, and you can see compared to the control roof, it has a tea-like color, and that's a lot of different organic substances that are in there. And so sometimes we do see higher concentrations of these contaminants, but since green roofs can retain some of that water, the actual amount that's in the runoff is less from the green roof. And then for reference, we also want to understand the same chemical species in both precipitation, and so this is a precipitation sample, as well as in dry deposition. And so here's a dry deposition sample, and you can see a lot of the different dirt and dust particles that have settled to the bottom here. And so we want to know, can green roofs filter out these dust particles?
Endla is an undergraduate working on a rain simulator.
So here is a plot from the green roof downtown at the On Center. And this contraption is a rainfall simulator. So basically we have water coming in at the top, and then we can control the intensity through here and through changing the diameter of holes in this drip former box. And right now we have an intensity of about 40 millimeters per hour, which is a good, like, intense rainstorm for the Syracuse area. And then we have soil moisture sensors coming into the plot, so we can calculate the water content as a function of time. And you can see over here we have a tube that will collect runoff as the plot gets more saturated. So this plot is placed on a 1-degree slope so that once the soil becomes filled, the voids become filled with water, the runoff starts to collect in this little container here. So right now there's a little bit of runoff in here, and eventually it'll get so high that it'll start pouring out here, and then we'll be able to measure the flow rate of the runoff coming out.
Lucy is a graduate student interested in hydrology, specifically in modeling.
So the water balance of the green roof starts where the rain precipitates down. Some of the water is held in the soil in the growth medium, and some of the water drains through the growth medium and exits the roof through a drainage system and enters a collective stormwater system. The water that is retained in the green roof is evapotranspired through the plants on the roof back into the atmosphere, where it condensates and then again precipitates. So engineers need to make sure that their designs are going to be accurate and efficient. So to do that, they often use model simulations to test their designs before implementing them. One of the models that is most commonly used by environmental engineers is EPA SWIM. I am working with real live data from our green roof and comparing it to an EPA SWIM modeled green roof to see how accurate it is. That way engineers will be able to know that the designs that they're working with within the models are real.
Yiga is a graduate student interested in energy conservation.
In my project, I mainly use temperature sensors. We have 5 temperature sensors installed vertically in different layers of our green roof. Based on this temperature profile, we can calculate the heat flux through the roof. In the summertime, a downward heat flux is observed, and in the wintertime, an upward heat flux is observed. Based on this heat flux, we can calculate how much energy can be saved through the green roof. In addition, because the green roof has a growth medium layer and sedum plants, and this layer actually is an additional insulation layers. So these insulation layers can prevent the roofing membrane go through the extreme temperature fluctuation, and this definitely can increase the lifetime of the roofing membrane. Compared to the traditional roof, we don't have to replace the roofing membrane that often.
As cities continue to grow, all those additional empty rooftops present an incalculable opportunity. Can you imagine green roofs like this all over the city? Yes, green roofs!
Yes, green roof!
We would like to thank the Onondaga County Facility Management Team for their assistance and permission to work at the Convention Center.